At a large airfield surrounded by farmland in central Washington state, an electric aeroplane recently made history. It's the biggest commercial plane ever to take off and fly powered by electricity alone. For 30 minutes on May 28, it soared above Grant County International Airport as crowds of onlookers clapped and cheered. Here are electric planes. They have arrived. However, the difference isn't quite as stark as it seems because electrical propulsion systems can be designed to be more efficient, meaning that they can cover more miles on less energy. But at present, this still leaves fossil fuel systems about 14 times more energy-rich than battery-powered alternatives. Batteries, not being fluids that merely slosh around, are also awkward in terms of their shape and bulk. Right now, the fuel nicely fits into the wing, says Susan Hank, an aerospace engineer at Concordia University in Montreal. Plus, a further hitch is that the weight of a battery stays the same even when it's dead. As a traditional aircraft flies, kerosene gets used up, making the aircraft lighter. That in turn reduces the amount of fuel it needs to stay in the air. Among those who have calculated what this means for actually getting electric planes into the air is Duncan Walker at Loughborough University. He worked out that the world's largest passenger plane, the Airbus A380, could only fly 1,000 kilometers with batteries versus its standard range of 15,000 kilometers. To keep its current range, the plane would need batteries weighing 30 times more than its current fuel intake, meaning it would never get off the ground. He writes, "These limiting factors mean that most industry experts think there are specific types of plane that will be electrified first. That mainly means they will be on the small side but not necessarily tiny." Engineers are currently trying to build a 180-seat fully electric jet that can fly for around 500 kilometers. The budget airline EasyJet has partnered with the aviation startup Wright Electric to design and develop such a prototype plane that, if successful, could enter commercial service as early as 2030. Its travel routes would be limited. Paris to London, for instance. Not much further. But narrow-body aircraft that fly short-haul routes of 1,500 kilometers or less make up around a third of aviation emissions, according to management consultant Roland Berger. By gradually introducing electric planes that could replace conventional aircraft on these short-hop trips, the environmental impact of flying could be significantly improved. One of the most closely watched hybrid aircraft experiments of recent years was the eFan-X, a joint project between Airbus, Siemens, and Rolls-Royce. The concept for the plane featured a 100-seat BAE 146 aircraft that was to be modified so that one of its 4 engines would be powered by a 2-megawatt motor. That's enough juice to power roughly 2,000 homes. The plan was to perform a test flight with the aircraft this year, but the project was suddenly canned in April. Riona Armsmith, chief project engineer for hybrid electric propulsion at Rolls-Royce, says the technology developed for the eFan-X has not been shelved entirely. "I think we just took a step back and looked at whether we really needed to fly these systems," she says. "I think we felt that we learned enough." There's no current plan to fly to a different prototype aircraft using technology from the eFan-X scheme, admits Armsmith, but many lessons were learned nonetheless. Not least, she says, how components such as electrical generators, cables, and switch systems need to be redesigned or built entirely from scratch in order to be reliable and safe enough to fly. It speaks to the fact that hardly anyone has adopted electrical systems to fly planes of this size before. Electrical components require additional insulation to ensure they wouldn't catch fire, for example, Armsmith says. And at high altitudes, high voltages take a greater toll on that insulation, so it needs to be very robust to be flight-worthy. This meant she and her team had to design brand new cables and switchboards. "You kind of go, actually. This is going to be a lot more challenging than what we thought," she says. Rolls-Royce still has other experimental electric aircraft in development, including the fully electric axle plane, which is due to take flight this year with the aim of setting a record as the fastest electric aircraft. Although a tiny single-seater, it's designed to reach speeds of nearly 500 kilometers per hour, and cover a range of more than 320 kilometers. So guys, this was all about today's video. Share as much as you can. That really motivates us to create more content for you guys. With this, we end our video. I hope you liked it. Do hit the like button down there, comment down your views, and do share with more of your friends. Take care, see ya!